This is our first solution on problem 20 from the AMC 20 from 2023. When n standard 6-sided dice are rolled, the product of the numbers rolled can be any of 936 possible values. What is n? Say we have we know that there are 6 faces on dice, and there are numbers 1 to 6 on dice. So there's 1, 2, 3, 4, 5, and 6. Now for easier computation in this first big step in our first solution, we exclude 5 because we want to derive a formula that helps us solve it and then add back the 5s later. So we have this array of numbers with all the dice excluding 5. So the product of the numbers can be rolled. So basically, you're doing this with, we don't know how much dice. We know it's n dice. So it's like 1, 2, 3, 4, 5, 6. This is very unclear. Now, we want to find what factors we can have. So this is this has prime factors. This is 0, this is 1, this is 1, this has 2, and then this also has 2 prime factors. So what we can do is, let's just see here. If we can break it into cases we can work with, let's see. So if we have n factors of 3 and prime 3 and prime factors, so n of 3, and then we have n factors of 2, n of 2 for all primes, and then 0 factors of 3, and 2n factors of 2. Well, we have an n case here and then a plus 1 here, so this is n plus 1. Now, for a second one, let's say this, n factors of 3, n minus 1 of 2. And then, let's see here, we have 0 factors of 3, and 2n factors of 2. And this is still n plus 1 solutions. And this goes all the way down the list until n. So let's just see. Well, first of all, in our first solution, we observed that there is 2n primes. So 2n primes, call that p. So this is 2n minus 1p. So if we go down all the way to n primes, what is that going to be? N primes, there's going to be n factors of 3, 0 factors of 2, and 0 factors of 3 in our second row, and n minus 1 factors of 2. Notice this is still n plus 1 solutions. Yeah. And, yeah. So, what can we do here? Well, can we go lower? Well, yes. As long as we have a combination of 1s, we can go lower. So, if we go into the n minus 1 state, 1 primes, we can go like this. N minus 1 factors of 3, still 0 factors of 2, 0 factors of 3, n minus 1 factors of 2. And this is still n plus 1 cases. Now we have that. Well, we have finally proved something out of all this. We see an emerging pattern here. So we can ideally erase all this and write a formula. So let's just compute a formula. Well, the sum, we can compute a formula by just summing all of these up. The total sum is going to be n plus n plus 1 times n plus 1 plus n times n plus 1 over 2. And then you add 3n plus 2 times n plus 1 over 2. But now, well, this second part is really what we want. That's like the key part, because if we make it a summation notation of all the values from n0 to n, we can make that formula really work. So we don't want to use n in our equation here. Let's use k. That's just most conventional, and we draw the sigma notation. So k is equal to 0. This is n over here. And we set this equal to 936. Why? Because in the problem, it says the product of the numbers rolled can be any of 936 possible values. So we have that. And the problem helps us a lot by giving answer choices. Otherwise, we would be explicitly testing n equals 1, n equals 2, n equals all the way to our answer. But we just have to plug in them at this point. So you can do that right now. It's pretty simple. And then you just find the average out of this outcome. So our answer will be 11 when you find that